Question number 5. The question is about structure and the bonding. 5.1. Figure 5 shows the part of the structure and bonding in diamond. This question is an AO1 question, and this question is coming from the structure of the diamond. A diamond structure is shown there. Let's discuss the diamond structure. Diamond is actually the allotropic form of carbon. So if you know about carbon, the carbon has atomic number that is C6 and 12. If you look the structure there, electronic structure there, 2 are in the first shell and 4 are in the second shell. It is going to make 4 covalent bonds. As I mentioned, there is going to make 1, 2, 3, 4. It makes 4 covalent bonds with 4 atoms. One atom is here, second atom is here, third atom is here, fourth atom is here. The question is coming here, explain why diamond A has a high melting point. Students usually make the mistake there. They try to give the information of intermolecular force. First of all, it doesn't have the intermolecular force, so don't try to write the word intermolecular force here. To explain why the diamond has a high melting point, the student must include the answer about the covalent bond. So there is covalent bond present between each carbon atom in diamond. As I mentioned in the beginning, it has a joint covalent structure. Each carbon atom has 4 covalent bonds. As I mentioned here, 1, 2, 3, and 4. So therefore, a large amount of energy is required to break these bonds between carbon-carbon atoms. Let's see the model answer. The model answer is, there is covalent bond present between each carbon atom in the diamond. It has joint covalent structure, means each carbon atom has 4 covalent bonds. Therefore, a large amount of energy is required to break these bonds. Don't include the words intermolecular or intermolecular forces between carbon atoms. There is no concept of intermolecular forces in diamond structure. 5.2. Figure number 6 shows part of the structure and the bonding in sodium chloride NaCl. It is an AO1 question, and this question is coming from the topic of the ionic bonding and the properties of ionic bonding. This is an ionic compound is given sodium chloride NaCl. So this is our chloride ion and this is our sodium ion. Just mention that Cl negative and Na plus. Sodium ion is surrounded by chloride ion and chloride ions are surrounded by the sodium ions. So it tries to make a joint ionic structure here. Question is, explain the conditions needed for sodium chloride to conduct electricity. So electricity can be conducted through any structure if there are the free electrons are present, or delocalized electrons are present, or free ions or delocalized ions are present there. If you look into the structure here in figure number 6, the sodium ions are surrounded by chloride ions and chloride ions are surrounded by the sodium ions. So it looks that these ions are not free. Sodium chloride cannot conduct electricity because there are no free ions are present here. But the questions come here, give the conditions here. So we have to provide the conditions in our answer. Sodium chloride can conduct electricity in 2 states, either in the molten form or in the dissolved form, mean aqueous solution of sodium chloride. When we dissolve it in the water, or we're going to heat up at a very high temperature, sodium chloride splits up into Na plus and Cl negative ions. When these ions are free to move, then they carry the energy with them. So explain the condition needed for sodium chloride to conduct electricity. Let's see our model answer. Note that NaCl has sodium ion and chloride ion Cl negative. Sodium chloride doesn't conduct electricity in solid state because there are no free ions are present. Sodium chloride can conduct electricity in two states, either in molten form or in dissolved form, mean aqueous solution of sodium chloride. So Na plus and Cl negative get free to move to conduct the electricity. 5.3. Figure number 7 shows the structure of sodium. This is the structure of sodium metal. I mentioned these are sodium atoms, and these black ones are showing the electrons are present there. The arrows are showing that they are moving freely within the structure. It is a metal. It belongs to group number 1. So the question is, describe how sodium conducts thermal energy. It is an A1 question. This question is from metallic bonding and properties of metallic bonding. So we know that all the metals can conduct electricity because there are a large number of delocalized electrons which are available freely moving within the structure. When they move within the structure, they are responsible for conducting electricity and thermal energy. The question about the thermal energy. So sodium is a metal, therefore it has a lot of delocalized electrons in sodium structure. These free moving electrons are moving throughout the sodium structure and transfer energy from one place to another place. Let's see the model answer. Sodium is a metal, therefore it has a lot of delocalized electrons in sodium structure, which we can see here. So these electrons are free to move within the sodium structure. These free moving electrons are moving throughout the sodium structure and transfer the energy from one place to another place.